Hello, geometry, and welcome to lesson 5.3, covering medians and altitudes, two more special segments in our triangles. So let's first kind of give an idea of what these things are. So when you think of the word median, right, you should think of the word middle or midpoint, right? So it's going to involve something about the midpoint in our triangles, okay? And then when you see the word altitude, and altitude is like when an airplane's flying, it flies at an altitude. This is a height, right? And the big thing to know about a height is that a height is perpendicular. So when we do altitudes, it's going to involve perpendicular, which is right angles. All right. So that's the two main things we'll talk about in today's videos. Okay. So first, what are the altitude and median that are shown in triangle ADC? So an altitude is perpendicular from a vertex to the line containing the side opposite. Okay? So if you take a look here, right? When I see perpendicular, I think of right angle. So this right angle means perpendicular, right? So again, that right angle means perpendicular. So segment AE is the altitude, is an altitude. Okay? Now, when I think of median, right, as I mentioned before, so a median is going to be a segment who has endpoints at the vertex and the midpoint of the side opposite, right? So when you think of midpoint, right, think of these two congruent markings. That means that B is the midpoint of segment AC. B is midpoint. So then the vertex opposite of that side AC would have to be D. BD is going to be your median. Segment BD is a median. Okay. So there's how we identify these special segments in our pictures. So very important paragraph here involving the definitions of median and altitude. Now, there is a concurrency of medians idea, just like there were concurrency of the angle bisectors and perpendicular bisectors, right? So the medians of a triangle are concurrent. And this point is going to be 2/3 the distance from the vertex to the midpoint of the opposite side, okay? So if we look at this picture here, right? So we have three medians, AD, CF, BE. Again, I know that because of the markings here, congruent markings, meaning that E, D, and F are midpoints. So if I take a look here, G, this point is going to be the point of concurrency of the medians. It's actually called the centroid. G is called the centroid, right? So this point G is the centroid. It has a pretty cool name. Okay. So if we look here, right, this whole 2/3 thing, AG equals 2/3 of AD. So AD is this median. So AG is going to be 2/3 of it. So for instance, let's let AG be 2x, right? So that would mean that GD here would have to be x, because 2x and x is 3x, and A to G, 2x would be 2/3 of 3x. Okay, so there's the relationship. So you can see that this piece here is twice the other piece. And again, it's a 2/3 to 1/3 relationship. Really, that's what I should have put, right? So this is 2/3, and that is 1/3. All right, let's go ahead and draw this using Desmos geometry. All right, so let's draw a triangle. Okay. Regular old triangle. I'll try and make it acute to start. So there we go. That's an acute triangle. All right, so I need a couple medians. So I need midpoints, right? So we can construct two midpoints. So if you click More Tools, Midpoint, pick any two sides. I'll pick this side. Again, if you hover over it, the midpoint shows up. Hover over it and click. There's the midpoint. So now I'm going to make two medians. So this midpoint has to be connected to the vertex opposite. So there's one median. This midpoint, vertex opposite, there's two medians. This point right here where those two medians intersect, that point is going to be called the centroid. So let's see if I can spell centroid correctly here. Label it as the centroid. Okay, and now let's talk about the different types of triangles and where the centroid is located. Okay, so if you think about the fact that it breaks it into 2/3 and 1/3. So again, if I make this segment here, so I'll label that one as 2/3. And if I make this other segment here, right, this segment right there, that would be it's not letting me do it. It's making me do the whole segment. Sorry. Oh, there we go. Okay, label it as 1/3. I got lucky. There, 2/3, 1/3. You would assume that the centroid always has to be inside the figure. So if I this is really acute here, right, inside. If I make this angle in the corner like a right angle, right, notice it's still inside. And if I make it obtuse, notice it's still inside. So for the centroid, for the median's concurrency point of concurrency, it doesn't matter where or what type of triangle you're dealing with. Okay. All right, cool. So let's take a look at a problem involving medians. Okay, so example 2, it says find the length of a median. It says what is the length of segment JN in the figure? So again, as you can see, I talked about the point of concurrency being called the centroid, right? So here, if we take a look here, I have 3 medians drawn. Again, I know because P, M, and N are midpoints. So Q is that centroid. So they want me to find the length of JN. So JN is from the vertex to the midpoint. It's the entire length of the median. So JN is made up of JQ and QM. Well, we know by the theorem that J to Q is going to be 2/3 of J to N. Well, they gave me JQ. JQ is 18, so 18 is 2/3 of JN. So to get rid of this 2/3, I'm going to multiply by the reciprocal, 3/2. And 3/2 of 18 is 27. That's the full length of JN, 27. So that would mean that this is 18. That would mean QN would be 9, right? And again, there's that 2-to-1 ratio, right? 2/3 to 1/3. Okay, one more question involving the medians here. So it says an artist wants to balance a triangular piece of wood at a single point so that the triangle is parallel to the ground. Where should he balance the point? So what we're looking for is we're looking for the center of gravity point, right? And actually, the center of gravity is the centroid of a triangle. So again, if we take a look at this picture, let me drag this over. So this is the shape that he wants to balance on this piece right here in the picture. So these dots represent the midpoint. Well, if I just find 2 medians, right? So let's find this median here, and let's do the short median here. Where those 2 points intersect, right there, that's the centroid. And that's also going to be your center of gravity. That is exactly where they're going to find it. So again, the process here, if you want some, So if you want some steps on how to find this, give me one second, what am I looking for? Back, eraser. So the first step here, step 1, you need to find midpoints of 2 sides. Find midpoints of 2 sides, which they did for us, the dots. Step 2, we need to draw 2 medians. And then step 3, identify the point of intersection. Point of intersection. And that would then be the centroid and also the center of gravity. All right, so there's our talks about centroid. Next video coming up is going to talk about the altitudes and what's called the orthocenter. All right, get ready for that.